So sometimes, depending on the circumstances, you might need to solve a right triangle. Solving a triangle means finding any information that hasn't been given to us. So if there's any missing measurements, I find all the remaining missing measurements. Um, a lot of practical situations, I don't have to solve the entire right triangle. I just have to find one particular piece of it, and we'll deal with some problems dealing with that momentarily. But let's go look through a couple problems where we're asked to solve the entire right triangle. And here's our first one, example 15. We're given that angle x is 25 degrees. We're given that side x is 4. We want to find the measurements of side y, side z, and the measurement of angle z. Now, one of the things you have to do when you deal with problems involving right triangles, if you're asked to find missing pieces of it, we always, if we're asked to find all the missing information, we start with the easiest thing first and work our way, to things that require more information about the triangle. However, with right triangles, whichever order I find these in doesn't really matter a whole lot because of the fact that um, when I deal with right triangles and finding missing pieces of them, I don't typically have to use anything I calculated previously in that right triangle to find any additional missing information. So, I can find side Y, side Z, and angle Z independently of each other without relying on one of those calculations to find the missing calculation. And I often do that in right triangles because of the fact that if I have the ability to do that, then if I make a mistake finding one of the pieces of information, I'm not necessarily going to carry over that mistake as I find other pieces of information. So, but I would still find the easiest thing first, and the easiest thing here to find, since I know two of the angles of the triangle, and I'm looking for the third as one of the missing pieces of information. All I gotta do is just realize, well, the three angles have to add up to 180, which means that the two acute angles have to add up to 90. So if I do 90 minus 25, I get 65 degrees for angle Z. That's pretty straightforward. Okay. So now I have the two sides to find. Now, typically, if I have sides on a right triangle that I need to find, I would usually, bring out that Pythagorean theorem. But the whole idea is, if I'm going to use the Pythagorean theorem to find a side measurement, I have to know the other two side measurements. And right now, I only know one. So the Pythagorean theorem isn't going to work for me here. So what am I going to do to find one of these missing sides? And the answer to that question is pretty simple. I'm going to have to use a trigonometric function to do it. That's the only other thing that relates the sides together. It only relates two of the sides together, because each of those trig functions were either like opposite over hypotenuse, opposite over adjacent, two sides. But I'm also bringing in an angle measurement as part of that whole, idea. So, for instance, if I want to find, say, side y, I'm going to focus my attention on the 25-degree angle only because of the fact that was the angle that was given to me. I could probably rely on the angle Z, the 65-degree angle, if I wanted to. Um, However, it was calculated. The chances of me making a major error on that are probably very slight, if any. But just to be on the super, super safe side, I'm just going to use the 25-degree angle that I was told angle X was. And since I'm looking for side Y, the reason why I chose the sign is because, well, I know the side opposite, so I want to make sure I'm using a trig function that has the opposite leg involved. So I'm either down the sine or tangent at this point. And Y happens, since I'm looking for Y at this point, happens to be the hypotenuse. So I'm using sine because the two sides I'm involving here are the opposite leg and the hypotenuse. That's how I choose it's the trig function sine. It's not always going to be the trig function sine. It really depends on what angle I'm using and what two sides I'm going to be using in my calculation. So these are decisions you have to make. Since y is in the denominator, I kind of think of like the sine of 25 degrees as a number. I would do my cross multiplication and get that y times the sine of 25 degrees equals 4. And then I'm going to divide both sides by the sine of 25 degrees. But I do know that y is 9.46 at this point. Now, Theoretically, if I wanted to, I could use the Pythagorean theorem to find z. However, you know, one, I rounded to get 9.46. So if I'm using this value here, it's going to be off when I find z because I'm going to probably be rounding from a calculation that I've already have a rounded value in. Secondly, what if I made a mistake as I calculated y? Then, um, any calculation of z using y as an answer or part of that calculation, it will be wrong by default because of the fact that y was not correct. So to avoid me, you know, carrying through any potential errors, on the safe side, when I try to find side z, I'm going to use only information again that was given. So I'm going to use the 25-degree angle, which was given. I'm going to use the x equals 4, which was given. And I'm going to use that to find z. So when I look at the angles involved, I have a 25-degree angle. I have the side opposite of it being the 4, the leg adjacent to it, which is z. So I have basically the opposite and adjacent. So I'm going to use the tangent of 25 degrees in the fact that that should equal 4 over z to calculate what z is. And you notice here I'm going to take the shortcut that I've mentioned before. I could just exchange, the sine of 25 degrees on the left there with the y. I do the same thing here with the tangent of 25 degrees and z. And I get that the z equals 4 divided by the tangent of 25 degrees, and that equals approximately 8.57. There's no units here, so there's no units for me to give. If you do have units given, if they said that x was 4 inches instead, well then these other answers I found should be in inches as well.